I want to talk to you today about one of the GED's favorite subjects, slope. So, as many of you guys know, I spend like way too much time in GED chat rooms or Facebook groups, really, talking to students about what's on the test. Um, and time, I hear from students that they took their tests and there was a ton of slopes. There was a lot of slope problems. And then sometimes there's slope problems in disguise that students don't even recognize. So I'm going to introduce you to the concept today. We're going to look at slope in one way. And then we're going to spend the next 3 classes looking at slope in 3 other ways and comparing and contrasting them. Because the GED has slope problems. It'll do slope from a graph. They'll have you do slope when you're given 2 points. They'll have you do slope from an equation, looking at the equation of a line and recognizing the slope. And finally, you could see slope show up in word problems. And then just to be particularly tricky, the GED often will feature problems where slope is shown in more than one way. So you might have, one in words, one in equation, one in a graph, one in a points form, and you have to compare. It can be really hard to do if you're not used to jumping back and forth with the different ways to look at slope. So anyway, that's my sell on why you should watch this series of videos, guys. Super important to algebra and to the test itself. And so today we're going to just look at what is slope. We're going to introduce ourselves to it, and then we'll look at slope maybe in the easiest way to see from a graph. Okay, so first of all, what is slope? Let's talk about that. Well, if I just use the word slope here, it's a common English word. So I think a lot of students, we have some background knowledge to draw on here. So like if I told you the road is sloped, I think that most of you guys know that means that it's slanted or it's steep. And so I think that my first definition, and this is not a mathematical definition so much, I mean, it's totally true, don't get me wrong, but we'll look at mathematically, how do we find it? But first, just like, what is it? So what is slope? Slope is a measure of steepness. Now, I have a lot of students right away, they're like, what? Measure of steepness. Well, remember, if I say measure, I'm talking about a number, so we are going to have a number. So some students will just tell me, hey, slope's negative, positive, or 0, or whatever, and I'm like, negative or positive what? Is it -2 or is it -0.2? Is it, +6 or is that positive 5/6? And so it's a measure of steepness. There's a number attached to it. Okay. And then of course, what is steepness? Well, if you say the road is really, really steep, that means it's really, really slanted. If you say it's not very steep, that means, it's kind of flat. So it's a number that represents how slanted a line is. Okay, great. Now, before we talk about how to find that number, I do want to just talk about there are 4 types of slope, 4 big, basic, overarching types. So let's go ahead and do that by looking at these lines over here. So I just drew a bunch of lines, and I just want you guys to take a look at these lines here. Realizing, first of all, that we read a graph from left to right. So when you look at these lines, I want you to let your eyes sweep from left to right. So like, let's take a look at this first line here, up in the top left corner. Would you describe this line as, if I read it from left to right, is this line going up or down or neither? And I think that it's easy enough to see that it's going up. And I hope you can see that if we go from left to right. So take a look here, look at these other lines. Do you see any other lines that appear to be going up? Well, not this guy. This guy's pretty flat. That guy looks like he's going down. But here's a line. Oh, I don't want that color. Hold on one second. Here we go. There's another line that looks as if it might be headed up. Now that one I'd say is going down. But here's another one that looks like it's going up. And another. Maybe there's another. I'd say that's going up. That one as well looks like it's going up. Now, are they all going up at the same rate? No, they don't have the same steepness, but we can at least agree that they're all going up. And so that's one way we can type our lines. We call lines that seem to be traveling up, they have a positive slope. Now, I mean positive slope just the same way that I mean a positive number. So there is some number that represents them when we go to measure the steepness. But for now, let us all just recognize that if a line appears to be moving up, remembering that we read our graph from left to right, then it has a positive slope. Whatever number represents it, it's going to be a positive number. Okay, great. So then you probably can see what's coming next. If a positive slope is the ones that are moving up, well then goodness, I'm going to guess that the opposite then would be a negative slope, and hopefully you would guess that as well. So it's like, okay, well, if a positive slope is going up, I bet that a negative slope is the lines that appear to be moving down. Okay, so let's go find ourselves some of those. Do you see any lines that appear to be moving down? I sure hope you do. I feel like Dora the Explorer right now. Where are the down lines? Anyway, sorry. Can you tell I have kids, y'all? Okay, so we are going to draw here some circles in orange. So it looks like to me that line is going down there. This one is also going down. Do you see any other lines that are sloping down? Yeah, we have some that are sloping really quickly down and another that's sloping really slowly down, but those are all sloping down. And so negative slope are lines that appear to be moving down as we go from left to right. Okay, great. Okay, so what else could happen? I'll take a look at these. I bet a couple of these lines look to you like they're not going anywhere. If I were walking down the street and I said to you, this street has no steepness, it has no slope, well, what would you expect your street to look like? Probably a flat line, huh? So if I say something is sloped not at all, it's flat, that's a flat line like these guys, these nice horizontal lines, well, that is what we call a zero slope. It's got a slope of 0. So we've already figured out the number for those, so we won't have to do any additional math. Or horizontal lines have a slope of 0. And you could write it, you'd spell it out, or you could just give me the number 0. What's the slope? It's 0. And those are for our flat horizontal lines. And I hope that one makes sense, because if you can remember that one, then the other one will follow. So the last case, let's look at our last 2 lines that we have here. In our last 2 cases here, we have a couple of funky lines that appear to be moving I don't know, up and down. And so I'll just circle them here for you. Let's take a look at these. Here's this line and this line. This is my other option. My line could appear to go up, it could appear to go down, it could be flat, or it could be this. This line that's going straight up and down, we call it a vertical line. It's an interesting question to ask you. How sloped is this line? How steep is it? And you might answer, well, Kate, it's infinite steep. It's like forever steep. It's falling off a cliff steep. And indeed, I would say that you're absolutely right. And the interesting thing about this is it's so steep, we don't even have a number to describe how steep it is. Let me just say that again. It's so steep when it's straight up and down vertical, we don't even have a number to describe how steep it is. And so what we will say here is we will say that this line has an undefined slope. Now, since this is a one that students forget a lot. They forget the undefined slope, probably because it's not as intuitive. I often joke with my students that a vertical line is like falling off a cliff. And guys, the second you start falling off a cliff, your life is undefined. You are falling off a cliff, you're probably about to die. You got an undefined life. Okay, so my vertical lines are my undefined lines. Great. So that's a nice little intro to slope, a little common sense checker. I always do this with students because they give me crazy answers that don't make sense. I'm like, we have to have at least a little bit of common sense that we can tell what lines would be positive, what lines would be negative, and so forth. So let's go ahead and see if we can do a couple of example problems of this nature. And here are the first few example problems that I would like to do. So we have types of slopes, and you can see the directions here are super simple. Identify the slope as positive, negative, 0, or undefined from each graph. So again, for each example, we'll do example 1 first. We are going to start from the left and move right. And you tell me, is my graph appearing to move up, down, or neither? Well, obviously it's moving up, and so I would describe that line as having a positive slope. Now you might be saying, Kate, positive what? Well, we will be learning that right after this concept. We will be learning, is it positive 3 or positive 1 or positive 1/2? We're going to be looking at that shortly, okay? But for now, it's enough for us to at least be able to identify that's positive. Okay, let's look at the next guy. So again, we're going to move down our graph line from left to right, and we can see that sucker moves downwards. And so that guy obviously has a negative slope. Beautiful. Now we have our next example, example 3, and I look at this graph and I don't appear to be moving up or down. I've got that nice flat, even. My road is not sloped at all. There's no steepness to it, and so that is a slope of 0. And so we have a 0 slope. Again, we could just write the number 0, but I'll spell it out. So that's a 0 slope. It doesn't slope at all. And then finally, last example we'll do here. You look at this line, and here we are. We've got that vertical line where it's like we're falling off a cliff. And how steep is that? Impossible steep. I don't even have a number to represent it. I'm going to go ahead and call that an undefined slope. What do I mean by undefined? I mean, literally, I have not defined it. I haven't given you a definition for that. You're just going to have to accept that we don't have a number that represents that. Okay, so wonderful. 4 examples, and let us head back to our thing because I want to give you a quick synopsis here. I have a little drawing that I use. I actually have 2 of them. So the first one is Mr. Slope Man. So let me bust out my 4 kinds of lines here. And does that kind of look like a face to you? I hope it does, because we are going to draw Mr. Slope Man here. So take a look at this first line all the way here on the top left. You can see that guy's going up. He's got a positive slope. And so Mr. Slope Man's left eye is a plus sign right under that eyebrow. Okay, now look at the, take a look at this top right line here. That line is obviously sloping down. So Mr. Slope Man has a little winky eye on the right-hand side for a negative sign. Okay, now we'll take a look at Mr. Slope Man's mouth down there at the bottom. He is pretty straight-faced, isn't he? But we know that a line like this, a flat line, has a 0 slope. And so I'll give Mr. Slope Man a tongue. He's got a 0 slope right there. Does that look like the number 0 to you? I sure hope so. And then finally, when I look at these vertical lines, those are the funkiest ones, those straight up and down lines. I know that those straight up and down lines are undefined, have an undefined slope, and so I will give Mr. Slope Man a nice U for a nose. He's undefined. So if it were me, I would totally make myself a little slope man, or here's your other option. Some people prefer the Christmas tree. Same exact concept. So we get our positive line, our negative line, the bottom of our Christmas tree. And every Christmas tree needs a trunk. Okay, so let's decorate our Christmas tree, okay? So again, on the, shouldn't a Christmas tree be red and green? I don't know why my Christmas tree is pink, y'all. I don't know how to Christmas. Okay, but on the left-hand side with that positive slope, I'll draw some pluses on my Christmas tree. We're decorating the Christmas tree, y'all. And y'all might laugh at me like, seriously, why is she making me do this? But I know that students who have a visual representation of an easy concept are more likely to remember it. The funny thing is when I teach you an easy concept, you guys often forget it because the easy things we don't have to struggle with, we don't have to muck about with. And when we don't struggle and play with something, our brain doesn't think we need to, it's very important to remember. And so you'll have all these easy concepts that you thought were so great, and then you won't remember them for the test. So do me a favor, give yourself a visual representation. So left-hand side of my tree, I have little plus signs. Right-hand side of my tree, I have little minus signs for the negative slope. And then the bottom of the tree will hang all our little zeros since that flat line has a zero slope. And then for the bottom of our Christmas tree, it has an undefined slope, so we'll give ourselves a U Christmas skirt. So I don't care if you do Mr. Slopeman or you do the slope tree, it'll help you visually remember the same information. Okay, so great. Now, the real question. I told you that slope is a number, it's a measurement. So how do I find the number? I wish it was so easy on the GED that you just had to identify positive, negative, or zero slope or undefined. Sometimes it is so easy because sometimes you have multiple choice problems, so you can use that to narrow it down. But sometimes you'll have to come up with the exact number that measures slope. Okay, so let's talk about it. If I wanted to measure how steep a line was, let's bust out a couple of our lines before. We'll look at some lines that we know have a positive slope. So that has a positive slope. It appears to be going up. That has a positive slope as well. It appears to be going up. This line has a positive slope as well. So you can see that all three of these are positive. But the question I have for you is, which is the smallest slope and which is the greatest slope? Well, obviously, they're not all the same. They're not all the same slope. If you were walking up some of these roads, you would feel a lot better than others. Okay, so you can see that some of the lines, like this first line, I'll say here, it has a really small slope. Looking at this first line here, it's just a gradual rising. And so I would expect that this guy of all of them has the smallest slope. I hope that would make sense to you. I'm expecting something small. Now, I look at that. That's a kind of a gentle slope. I wouldn't mind going up that hill so much. But then let's try looking at the next largest slope. Obviously, this second line over here gets a little larger slope. You know, it's a little steeper. I would be a little more reluctant to climb this hill. Maybe if I was trying to lose weight, I would go tackle that hill, but I definitely take some water with me. Okay, and so you can see here that I have more of an in-between kind of a slope. I would expect this to, if I were numbering it, to be a bigger number than the other one. And so I'm going to call this a medium slope. Certainly, it's not the only line of medium slope I could draw. Okay, now, but look at this guy. You wouldn't even be able to climb this hill unless you had some special equipment. We look at this third line here. You would probably need a grappling hook. You might want some spikes on your boots. You'd be grabbing onto tree roots. This is one steep hill. I would expect this to have a large slope. So, let us define slope one more way. So we already said slope is a measure of rate of steepness, but how do I measure it? Okay, so this is how you measure it. To measure slope, make a ratio of how fast the line is climbing, like how fast it's going up, to how fast the line is, I want to change my word fast, how much the line is climbing to how much, that's a great word, guys, how much the line is moving over, you know, how much it's going over. So we're making a ratio of how much it's going up to how much it's going over. Okay, so a lot of teachers abbreviate this concept rise over run. In fact, this might be the first time this whole day that you've been like, oh, Kate, I know what you're talking about now. My teachers have said that, rise over run. That's what I'm talking about, because make a ratio means make a fraction. So we're going to start, we're going to talk about how much our line is rising, how much is it going up, okay? And then after we're done figuring out how much it rises, we're going to make a ratio. We're going to put that over the run, how much my line is moving left or right. Rise over run is one totally acceptable way to find slope. And it is the easiest way to find slope from a graph. And you might be thinking, well, am I going to find slope other ways? You are. But when we have a graph, it's easy. We can count the rise and count the run. We're going to count movement between points. Let's go take a look at some example problems so I can show you what I mean. Okay, so these problems here say find the slope, calculate the rise and the run to find the slope of each line. Okay, so a really helpful hint is that if you want to calculate the rise and the run, those are both movements. How much does my line rise is a movement. How much does my line run is a movement. And so you are going to have to move from point to point. We're going to count the rise from a point to a point, okay? And then once we're done with that, we're going to count the run from a point to a point, okay? So let's go ahead and I'll show you what I mean here. So here on this graph here, they've marked a couple of points for me. So I'm going to go ahead and use those points. The good news is even if I use different points, I'd be safe. But I'm going to go ahead and use the ones they marked for me since they're already there. Okay. Now I'm going to start from my leftmost point. Do you have to start from your leftmost point? No, but I found that students who do make less mistakes with their negatives. So that's my expert hint. I would start at the left. And again, there's generally more than one way to do things in math class. So there would be a way to start at the right and go the other way. You would just have to juggle around a lot more negative signs. And since students tend to hate negative signs, I start from the left. The first thing we're going to do is we're going to do our up or down movement. We're going to rise. That's called our rise. We're going to decide how much of a change there is going from this left point to this right point. And I'm only going to do the up change. So I'm going to start here and I'm going to move up. Now, a lot of students will tell me that's a rise of 1. Be careful. I'm counting. I'm not asking where I end up. So I'm counting. If I start from -3, let's start counting here. I go up 1, 2, 3, 4. I just rose 4 units. That is my rise. Now, let's go ahead and take a look at our run. So starting from where I just left off, I'm going to run right. And if you start on the left, you're going to always end up running right. And the reason why I like to do that is because as you go off right in the X direction, you're going positive. So that keeps my my run a positive number. So how much did I just move over here? Well, I just moved 1, 2. So I just ran 2. So your rise over run is literally 4 over 2. So, you know, I need some more room to work over here. So I'm just going to type that. My rise over my run. How's my crooked line? Y'all will have to forgive me. Okay, my rise over my run is going to be equal to 4 over 2. Now, there's an interesting thing about this answer. Because this answer is totally and completely correct. It is a correct and true answer. However, it is not done. So there's something super important you need to know about fraction answers, ratio answers. They should be in the simplest form. So sometimes that means reducing fractions. So I can reduce fractions. Sometimes with slope, that means dividing fractions. You might say, what do you mean dividing fractions? Well, another way to think about the number 4 over 2, remember that a fraction bar means the same as divided by. So it's the same as 4 divided by 2. If your numbers divide perfectly, there is no reason to keep this as a fraction. Just go ahead and divide them through. 4 divided by 2 is 2. And so the slope of this line is 2. The slope of this line is 2 because 4 divided by 2 divides to equal 2. Okay, great. So we finished 1. Let's go on to the next example. This one's a super important example, and I want to show you then why I asked you to go from left to right, because here's my leftmost point, and there's my right point. And I want you to notice that the first thing you're supposed to do is rise. So a lot of students make a mistake. Don't be the student who goes and does this first because they're trying to go from left, right. No, no, no. You want to look at your up-down movement first. We're doing rise, over, run. So let us start with the up or down movement. You can see the vertical movement, we call it. On this line, we would actually have to go down. Can you see that? So it shouldn't surprise you to know that that's not really a rise. That's a fall, or a negative number is the way I think of it. So let's count how much. I said I went down 1, 2, 3, 4, 5. It looks like I fell 5 if I count that rise. And so my top value is going to be a negative 5. A fall, that's how I think of negative numbers of 5. And that should make sense to you from the problems we were doing earlier, because this line slopes down. It ought to have a negative involved in it. Now let's look at our run here. And as long as we're running right, our answer will be positive, which is why I like to start at that left point. And let's count. That is a run of 1, 2, 3, 4. Did I count that right? 1, 2, 3, 4. Yes. And so that is a run of 4. Okay. So if I had a rise of negative 5 and a run of 4, that means my slope is going to be negative 5 over 4. So negative 5 over 4. Now let's take a look and let's think about this number. Remember that I said that we should simplify if possible. So I take a look. Does negative 5 divide nicely by 4? No, it doesn't. I would get pieces or parts if I were to try to do that division. So I won't do that division, but I should check if the fraction can simplify. Now, I look at this and I'm pretty good at reducing fractions. Reducing fractions is simple for me, and so I can look at it and say it's already reduced. But what if you're that student who's always struggled with fractions and doesn't know how to reduce them? Expert tip, your TI-30XS knows how to reduce fractions. It knows how. So you can literally go type this number into your calculator. Here's how you would do that. Okay, the first thing you would do is you would pick up the negative 5. Actually, can I have the first thing you do? Make sure you're in the right mode. Can you confirm for me that you're in math print mode? In order to do that, you're going to hit the mode button on your TI-30XS calculator. You're going to arrow down over the word math print until your cursor's blinking on it and press enter. Okay, press enter on math print, and once you've done that, you can clear your screen. Okay, great. So now that I know that you're in the right mode, you might have been there already, but now that I'm sure you're in the right mode, now let's talk about how to reduce fractions. And math print is my preferred mode for working with fractions every time because it's more intuitive. Okay, so what I'm going to have you do is get a fraction bar going by typing the N over D button. It looks like the letter N over the letter D. N over D button. And I'll just do my best to write it out here. So you'll type that N over D button. That will give you a fraction bar. You should be able to type in a negative 5. Be careful not to use the minus sign. Use the negative sign on the bottom right. And then you can arrow down to the bottom of your fraction so that you can type in 4. All you have to do is type in that fraction in the correct format and then press enter, and your calculator will do the reduction for you and all the other simplifying as well. And so you'll see that when I type into the calculator and press enter gives me the same answer. And so I can be sure that this thing is simplified. Okay, so you can use your fraction skills to simplify, or you can use your TI-30XS calculator. If you were doing this on the GED, you would have that available to you. Okay. One more example for us to look at. So let me just clear this. Actually, let's do this one. Let's do this one because it might reduce. So let's take a look. Okay, so again, I'm going to start from my leftmost point and move to my rightmost point. Did it have to be those points? No, it didn't, but those points are going to be super nice because they're directly on corners. Like, see here, this is not directly on a corner right here. This is in between right here. And so that would be a hard point to use. So this is a good point to use. Okay, so let's see how far we'd have to rise first to get from the leftmost point to the right point. So I'm having to rise 1, 2, 3, 4, 5, 6, 7. I have a rise of 7. And then my run, I'm going to start from there and I'm going to go over 1, 2, 3, 4, 5. 7 over 5. And will 7 over 5 reduce? It will not reduce. And again, if you do not believe me, you can go ahead and type that into your TI-30XS calculator. And I promise you, 7 over 5, if you type it in fraction form and press enter, will still come out 7 over 5 because it does not reduce. Okay, let's go on to our next one. So next examples, it says draw a line through the point for the given slope. So this time they've given us a point, but they haven't given us the slope. So let's go ahead and look at how we could draw this slope. So remember that I taught you that the top number is your rise. The top number is your rise. Where's my annotate? There we go. So we have a 2 up here for our rise. We're going up 2. Notice it's a positive slope, so our line is going to go up. So we have a rise. Oh, this one already is going to give us problems. I can see it. A rise of 2. And we have a run of 5, a rise of 2 and a run of 5. Now, let's take a look at this on this graph. If I wanted to rise a 2 from my point, I would start right here and I'd go up 2. Now, that's not the problem. Hopefully you can see where my problem is. If I now wanted to run 5, remember I said we're supposed to run to the right. 1, 2, 3, 4, 5. That would take me off the graph. Now, can I draw a point there? Well, absolutely. I sure could draw a point there. But if you were on the GED, you wouldn't be able to go off the graph. I can go off the graph because I'm using a worksheet. But if I was on the GED, I wouldn't be able to. So what are we going to do? So this is a really good thing that you should know. You can always get around this by doing the point on the opposite side. The point on the opposite side. Remember, a line goes on and on forever. So yeah, there's a point up there, but there's also going to be a point, if there's one top right, there's also going to be a point on the bottom left. Imagine that this line was actually drawn between these points. There's going to be one down here somewhere on the bottom left. Okay, so how could I figure out that line? Well, what you can do is if you go off the graph, you can change the signs of both the numbers. Let me say that again. You can do the same slope by changing the signs of both the numbers. So doing 2 over 5 is the same as doing -2. I changed -2 sign, but careful, don't just change one number's sign or you're going to change the way my line is sloped. You must apply that opposite rule twice. You must change both of the signs numbers if you want to get to the same line. So -2, -5. So let's take a look at how I could do -2, -5. So again, instead of going up, I would go the opposite direction. I'd go down, -2 rise. And then instead of running right, I could run left. Running left is a negative run. I could go left and make my point right there. Now take a look. Let's see if it really worked out the way I said it was going to work out. Did it really give me that line? If I go through, can I go through all 3 of these points? And look at that. Can you see how that's the same line there? And so that is how I can do a slope of a line that when I can't see one of the points. So let me just erase all this messiness so you can see my final answer. I'll erase this one, but I'll keep this little guy so you can see that. Okay, so instead of going up 2 and over 5, since I didn't have enough room, I went down 2 and over 5. And let's bust out a line, and let's do it in blue so you can see the line. They're supposed to have 2 arrowheads. So I just want to make sure that I do that for you. Okay, so there's our line that goes through those 2 points. This is just my scratch work, these 2 red arrows. I want you to be able to see the difference. That's my scratch work of my counting. I want you to visualize what I'm counting. But your final answer is just to have this line going through those 2 points, okay? So let's try one more like that. Okay, so let's do our scratch work in red again where we start counting. Now this one, notice, has a slope of -4 sevens. -4 sevens. Now the negative's out front, but we can go ahead and count the negative with the 4. And I think that's the easiest way to do it. I'm going to go down 4 instead of going up 4. I'm going to rise -4. I'm going to go down 4. So 1, 2, 3, 4. That'll take me to there. And then from there, I'm going to run 7. And since that is I use the negative up top. You don't use the same negative twice. It's now been used up. So now I'm going to run +7. I'm going to run +7. So starting from here, I'm going to go 1, 2, 3, 4, 5, 6, 7. And that's where my second point will be. Now again, those little red arrows are just scratch work, but you should draw the point. Would you like it better if I drew the point in blue so you can distinguish your scratch work? So now I have my 2 points, and 2 points is all it takes to connect a line. So I will put a line through the 2 points. And if you're drawing yours by hand, please, 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 please make sure, I don't like that line because it doesn't go through my points. There we go. That looks better. Please make sure that you draw the little arrows on either side of your line to say it goes on and on forever. Beautiful, beautiful, beautiful. Okay, so lots of examples, lots of things for you to try with slope. I will post up practice problems with this video so that you can give it a practice. I just had a student tell me today, oh my gosh, I watched YouTube videos all weekend long, and I think that I am in math overload. Is that possible? And I had to say, you know, it really is possible. If you don't muck about with something, you won't remember it, period. That's where the real learning happens, when you practice it. Even if you watch my videos and it's like totally clear and you're like, man, when Kate teaches things, it's so clear. I hope you're saying that. But even if you think it's totally clear and you choose not to practice it, you probably won't remember it on the test. That's the likelihood. Because it's not the things that are so clear we remember. It's the things we experience. So go play with it. Go try this for yourself. All right. If you have any questions, make sure you ask them. I'll be happy to answer them. And I will see you next time when we do slope from 2 points.